Okay, good evening to all of you. Welcome to new start. This is data visualization. I'm very excited to start this journey to all of you. So today is our first lesson. Today we will look for model insights, coefficients, and feature importance. This is our first lesson, week 17 and lesson 1, coding tutorial. Before moving ahead, we will go on to the overview of the course 5, that is data visualization, what we are going to cover up in this stack. So in the first week, you will learn about the model insights. As you have learned in the previous section, what you were doing with the modeling, what about predictions and everything. Here you will get a chance to dive more deeply inside the model. In this, we are going to covering working with sklearn version 1.1 plus, extracting and interpreting the coefficients and feature importances, applying model explanation tools, that is shape and line permutation importance. And in the week, we will go over the time series in the Python. That is, we will cover up in detail the date time objects and time frequencies, pre-processing data for time series, normalizing time series, and time series statistics. So this week, we will work on the time series using Python. In the third week, we will cover up introduction to Tableau. That is how you can install and using Tableau public version, Tableau fundamentals, creating and sharing Tableau stories, time series with the Tableau. And in the week 4, we will dive more deeply into the Tableau, that we will cover up in the advanced Tableau, combining and connecting the related data, making an interactive dashboard, preparing the Tableau data analyst certification. So these 2 weeks will help you to prepare for the exam of data analyst certification by covering up these things. You need to do more work on top of that, but it is really helpful for you to start the preparation of the Tableau data analyst certification. So this is all about this Stat 5. So now we will talk about the announcement and reminders. Code reviews and 101. You can, the code reviews are open on Monday, Wednesday, and Friday. And in this is a great opportunity for help on the hands-on assignments, core assignments. If you are facing any issue in the live classes or any content of the LP, you can book a 101 and you can message me on Discord, you can email me. And this is a Calendly link. And you can click here, you will find the spot and you can book it. This is highly recommended. It will help you to like update your skills and help you to writing the codes and everything and making a more understanding about the concept. So I will highly recommend to book the group code review number 1, in which you will get a chance to talk to your peers as well in the group code review. And in 101, you will get a chance to talk with me or discuss with me the topics as a 101. And you can reach out on the Discord if you get stuck anytime. This is DS Data Viz Nirja. The TAs are also available to answer your questions over there. And if you if you see like there is a no schedule free, then you can do one thing, you can DM me on Discord. Okay. And you can also email me. I will reply as soon as possible. Okay. Now we will talk about the your stat schedule and the readings which you need to do before the next lesson. So today we are going to learn about the model insights and the feature and coefficient importances. In the next class, we will talk about the shape and line tools. So before that, if you can go through these readings, shape local explanation, more local shape plots, and live local explanations. This will help you in the live class to understand the concepts. So this is like recommended. If you do it before, jump into the next class. And this is your assignments. Core Project 1 Revisited Importances and Coefficients we are going to cover up today in the class. Core Project 1 Revisited Global Explanation we will cover up in the next class. And core project 1 local explanation, we will cover this part as well in the next class. So these are the 3 assignments. And this is heads up for the core project year 2 and 3. This is the SHAP package recently changed a lot of the code and functionality. So the LP is using the latest version of the SHAP, that is version 0.4.1. Make sure while you are working, it is like working correctly and it is the updated version. If you Google for the help with the SHAP, some solution may not work with the same way. Then you can reach out on Discord if you get stuck anywhere in this. Okay. Any questions about the announcements and the reminders? Any confusion in this? So this is just the optional extended practice assignments. This is not on the stack schedule. Okay. This is you can like larger than the practice assignment, same data set on the LP using the different target. If you are interested, you can go with these one. Okay. If you have extra time, it is a good chance to do the practice and learn more using the tool live and share. So before moving ahead, let's do one warm up. This is a 5-minute breakout room activity, and this is a link to your notebook. You can make a copy of this, and you need to answer the questions here. This is the data set. I have written the all. This is your house sale price data set. The EDA is done little bit, which is required, and its feature versus its target. Pre-processing is done. In this, you need to answer these questions. Does this model have a good MAE? Does this model have a good R squared value? Is this model overfit, underfit, or neither? You need to answer only these 3 questions. Okay. I will open the breakout room. If anybody, I will share this link in the chat as well. If anybody have any confusion, that include this one. Okay. And I will open the breakout room now. Okay. And all students are in the breakout room for the warm up.
Just gonna give them a couple of minutes if you're okay with that, Energy.
Yes.
I mean, I think they'll be fine because there's only 3 minutes left. Did you give them only 5 minutes?
Right, all are back. Okay, so from room 1, who is going to answer or explain these questions? Anyone? And
All right. Let's see. For question 1, good MAE. It was not a good MAE. It had a pretty large error for all the housing prices, especially when we looked at all the different values for the different houses or for the different housing prices. It was pretty staggering. Question 2, good R squared. It was not a good R squared. At 0.5, I mean, we want to see anywhere at least in the 0.9s. Or above. And then question 3, we decided it was underfit. There's not really a lot of variance between the R squared between the train and the test. So it could be potentially neither because they're not too wildly different. So
yes, Joshua, great answer, great explanation, good teamwork. And what about anyone from room 2?
Yeah, so we talk about we didn't have the time. We tried to run the whole thing and we get a little bit behind, but yeah, we noticed the same thing because there is it's a low variance, but because the performance is very poor, especially in the test, has a high bias. We were checking about the MAE, which has the same units that the target, but we couldn't go above. I don't recall if this number is close to the average. I think maybe that's what is about the question number 1. For Q3, I will say that this is underfitting, if I remember correctly, based on the rules that we learned the past stack.
Okay. Okay, thanks. Good, great. Okay, does this model have a good MAE? We can say this is not a good MAE, right? But we can accept it. It's not, we can say very good, but we can accept it. And does this model have a good R squared? Not, right? But if we look for the there is a variance between the difference between the results of train and test, then we can consider it, but it's not a good model at all, right? Is this model overfit, underfit, or neither? It's a neither, okay? Because there is a very small difference in between your train and test, okay? So these are the answers, and later on I will share the solution as well at the end of the lesson. So let's jump for the lesson. So before moving ahead, this is the key scikit learn version 1.1 updates. Earlier you use the make column transformers when you do the pre-processing. And then sometime you need to get the features name. You need to do a lot of work in earlier version. You need to write down the steps, then you will get the features name. But now in version 1.1, you can use the get features underscore names underscore out method to get the features name directly from the preprocessor. So this is a very, very good and benefits like this method for you. You don't need to write a too much pieces of the code. Model save features name in a features name in attribute. You can directly save the features name. No, sorry. Your model also have the features name saved in it. You don't need to if you would like to take the features name out from the model, you can also do that using the features underscore names underscore in underscore. So this is the very good updates from the version your scikit-learn 1.1. You can use any of method whenever you want to get the features name. Today's learning objectives are students, you will be able to learn, explain the difference between the glass box models and black box models, difference between the model predictions and modeling for the inference, extract and interpret the coefficients and feature importances, select the most important feature for model building. So these are the topics you are going to learn today. After this lesson, you will do all these things. First of all, we will jump for explain the difference between black box model and glass box model. here, if you see, this is the top level about the, like, what is black box, what is glass box. If all of you look here, this is the input of your data. This is your model and this is output. So your model is working at his end and giving you the output. But it looks like we can't see anything inside this. You don't know what is happening inside this. So these kind of models known as black box model. Okay. And here in the second picture, you can see this is the input of your data. And then this is the model which is working and giving you the output. So in this, we can see this is very transparent. I can see here is the equation and with the coefficients, it is working with using this equation. I can see what is happening inside the model. So this is the case of transparency. We can see, right? And this is known as glass box model. We also call it white box model as well. Okay. So what is the major and key differences between your black box model and glass box model? As we were talking about first we will talk about the glass box model. This is your model is very simple and interpretable. How? Because in the previous slide, I have shown this picture, we can see the equations, how it is calculating the weights, how it is calculating, like finding the coefficients and giving you the output based on the given features. Very transparent. So this model is very simple, easy to understand. It is interpretable because we can see what is happening inside the model, right? But it gives a low accuracy. But I would say here, this is not for sure. This is not like the fixed thing. It will give you the low accuracy. Sometimes it will give you the good accuracy as well. It totally depends upon your business problem, your type of data set, features, how you are doing the EDA, pre-processing and everything. But as comparison to black box model, sometimes it gives a low accuracy. These, the examples which is belong to your glass box model is linear models and decision tree models. Because inside that we can see the equations that is transparent to us. And this is all called these models like linear regression, logistic regression, polynomial, multilinear and decision tree. These all are your glass box model. What is black box model? Now, if we talk in comparison to glass box model, this model is very complex. We can't see anything inside this model. What is going on inside this? We got a good accuracy, high accuracy, we are happy. But we don't know which model, which feature is using most. This model is not easily interpretable because we can't see anything inside this. This model give a high accuracy. This is also true. If you have the black box model, you have a very complex data, large data, then we prefer to apply the models which are complex. And this will give you the high accuracy with those data sets. Here, the example which is belong to your black box model is neural network, random forest, XGBoost, LightGBM, and other deep learning models as well. So these all are our black box model examples. Neural network, if we talk about neural network here, we know it has a many layers. It has a many neurons. It assigns the weight automatically according to to make a good accuracy, good prediction, or try to make it correct prediction. So it uses different like the weights of the function, neurons and layers. So we don't know how it is assigning the weights inside that. Okay. So this is a very good example of the black box model. What questions do you have about the glass box model and black box model? Right, take your time. If anything come up in your mind, you can type in the chat as well and you can say as well. Okay, one question from all of you. Like, what was our goal for model building previously? Till so far, you were doing the modeling, analysis, everything. So what was your goal? Great. right? Yes, great. Thanks for your answers. So now we will talk about the model insights. Like we have discussed, the model insights are two types, black box model and black box model. Now we will dive more deeply into this. Modeling for predictions. If you look at this picture, this is here, data is going inside the model, and this is the predictions, right? Earlier, our goal was we only care about the predictions. My accuracy should be good. My model should predict the correct things. My model predict 90% correct, 95. This was our goal, right? We were like, we don't care about what is happening inside that, right? We were never concerned about that. But in this case, we were not able to see inside the black box model. And these kind of models are known as a black box models. Black box model give you the high predictions, high accuracy, but it is tough to interpretable which feature is used most of the time to make a correct predictions and most of the predictions. If we take an example of house sale price here, let's suppose you have a three features here. You have a square foot living, you have a number of rooms, you have a number of bedrooms, you have a number of garage, and then you put that data into this model, right? And it give you the 95% accuracy, but you don't know which feature was used most of the time by the black box model. Was it square foot living? Was it a number of bedroom? Was it garage? What was, right? So this is the like black box modeling for predictions when we talked about. Okay, now we will discuss one example here again. What if our model is used for determining if applicants are granted to loan or not? Let's say we have a 4 applicants here. We give the input to this model. Now my model say first applicant and fourth applicant is approved for the loan. But 2 applicants are not approved at all. Now the question mark is, this is the data. If you go like deeply into the data set, you look for specific sometime, you see, oh, this is the same data, but why this is disapproved, right? And we don't know what is happening inside this. We can say like, why did our model deny the application 2nd and 3? This is a question mark, right? We don't know. So maybe we can consider like your black box model is just like flip a coin. When you flip a coin, we don't know head or tail will come. We are just thinking like that. If this is the input, model will say yes. If this is the input, model will maybe say no or yes, right? So this is the biggest problem with the black box model when you do the prediction using these models. Like if we talk about neural network here, XGBoost or other models, complex models, it give you the high accuracy, 95%, sometimes 90, 92. But when you want to improve it, it's tough for you to interpret it, which feature is important. Now we will talk about the modeling for inference. Earlier we talked about the modeling for prediction. Here we go. Now, here, when we are talking about the modeling for inference, our goal is look for the relationship between the feature and target. We don't bother about the accuracy. We don't bother about the predictions. Here we are interested to see inside the model how the features are highly related to your target, right? In this, if you look at this picture, here we go. In this, y is equals to m1 x1 plus m2 x2 plus b. So this is our linear regression equation, right? These are the coefficients. This is your features and this is your constant term, baseline, right? And then it will give you the output. See here the coefficients, right? We can see how the weight is assigned by the model and everything. So now we are more concerned about the relationship between the feature and the target. That's why we are talking about here modeling for inference. Now, we still care here about the quality of the prediction as well, but it is not our primary focus here, right? Any questions till so far? All right. So this is a summary of the modeling for prediction versus inference. So prediction, inference. So what is prediction? When we are interested in predicting the target from the features. Inference, when we are interested in looking into the relationship between the feature and the target. So this is our goal, right? So in this, how would you answer these questions? Like develop a best model considering all predictions for predict Y with high accuracy, low error. If this is your goal, then you can go with the black box, right? When you are not interested to look at which feature is important for the target, which features are going to use most of the time in that case. So in this, how can I accurately predict new data points, right? Here will be the question because we don't know what is going to happen inside the model. Example, what mortality levels does the model predict given a certain income and education level? Okay, so this is the example. Now, if we talk about the inference here, when you are interested in estimate an association between an outcome variable and a predictor, we are interested in looking at inside the model what is the relationship, how strongly they are connected with each other, the features and the target. So now answer this question. What do the relationship between the variables mean? Okay. If this is your goal, then you can go with the glass box models. Okay. Which has the biggest impact on the mortality, right? Because it will help you to tell here which feature is used most of the time to predict the rate of the mortality based on the features. Is it income level or education? Okay. So these are the examples about the like a glass box model, black box model. What is a model prediction? What you need to look for in that, right? When you should use and what is the model inference, why we use it, and this is a summary of that. Any questions till so far? Any confusion in this? You can type your question in the chat answer. Okay. Let's do 2-minute breakout room activity. It will help me. How much did you get from the previous slides? So you can click here and you only need to answer this question. The key difference between the black box model and glass box model. Okay. So I will open a breakout room for 2 minutes. Bye. Okay, so the room number 1 says complex model versus simple. We can see what the model is doing. versus not being able to see. This is correct. Good. Great. So we are waiting for the another room. Great. Okay, so everyone is here. Great. Both from the rooms are doing great. Thanks for your responses. Really appreciate it. Now we will move ahead. Now, till so far, we have talked about the glass box models, your in model predictions and inference. Now we will talk about the coefficients and the feature importances. How you do that, okay? Using linear regression and decision tree. First of all, we will go over the definition. So what is the feature importance? Feature importance means we are interested to know which feature is used most of the time, right, for the prediction, and which feature has a high predictive power. This is the feature importance. So we can choose a feature from the data set before jumping into the deployment. It will help, it save your time, and it help you to know about the good features. In this, there are many type of feature importances, that is coefficient and feature importance. This is we are going to discuss today. Linear and decision tree feature importance. This is we are covering today. And permutation feature importance, we will cover up this in next class. Here we go. Now look at this example. This is here when we talk about the feature importance, right? And if we are looking for the linear models, decision tree models, then we are going to see the coefficients value, because this is belong to glass box model. We can see the weight of the each coefficient, we can change it, right? And we can make changes and make the good accuracy with it. Okay. Now look at this here. Here we are again taking the example of house sale price. So here on the right side, we have the feature. Here we are checking the relationship between the first feature, square foot living, and the target price. So here, can anybody tell me what type of relationship is this? This one. Is this positive? Is this negative?
Positive, correct? Positive.
Yes, great. Because if the square foot living of the house is increasing, price is also increasing, right? And if we go for the here, second feature, bathroom versus prices, it is also showing the same thing, right? And if we look for the bedroom, this is showing the relationship like this way. This is not going in the same direction, but it is going in this way up, right? Where somewhere when the number of bedroom are increasing, the price is also decreasing here. Same case is here as well. Okay, this is not linearly going up with this, right? This is here where the feature importance, coefficient feature importance jump in. So this is a formula for your linear regression, y is equals to mx plus b. This is your what you are trying to predict. This is your rate of change of slope. This is your feature, and where your line crosses the y-axis. Okay, and this is a formula. So in this, what we do, we calculate the coefficients here, and then we, based on the value or score value of the each feature of the coefficient, then we can decide which feature is important for our model. We can also call it glass box model as well, because this is transparent, right? We can see the equation here. And now we will talk about the decision tree feature importance here, right? So in the linear regression, we saw the equation. We can see the coefficients value. When we calculate it, we will visualize it. Soon you will see the visualization as well. That will make more sense to you again. Okay. So in this decision tree, I took the maximum depth 7, and this is the output. Okay. Now look at this picture. If we open this big picture here, Okay. So this is square foot living, right? Squared area. And then these are the samples it is taking and this is the value. And this is splitted further in the decision tree, right? And then if we go with here, we can see this feature is again used. This is again split by your decision tree. It is making another decision tree. Sorry, node here. And then if we go here, it is again using here. And if we go bottom, it is using year built here, right? And then other features. But most of the time, if you look at these, most of the time, year built and square foot living a feature is used by your decision tree, right? And if you want, if you see in the decision tree picture, which feature is used by decision tree most of the time to split into the nodes, this means that feature is very important for your model because it is used by your model again and again to split it. Okay. If you want to look at it again like this is year built and this one. Okay. And I will show you in the next picture. This is, I have highlighted it, which I use the most of the time. So before that, this is like, it was a difficult for us to look at the big decision tree picture, right? And if you do the plotting here, this is a simple bar, your plot. Here, when you plot this decision tree regression bar chart, you can see square foot living is coming at the top, right? Then year build, then bathrooms, then floors, then waterfront, then conditions. So whenever you plot this graph, the top features are known as the most of the time used by your model. Okay, used to split the your data to do for the predictions. And on the x-axis, we can see the importance, right? Sorry? Any questions? Okay. So now this is the like visualization, right? This is an alternative way to understand the importance of the feature using the bar chart because it was difficult to look into the big tree chart, right? Which feature was used most of the time. So in this, like the feature importance is for every feature used by model sum to 1. Okay. The more often the tree split using feature, the more important the feature is. This is what we have discussed a few seconds ago, right? So if you look at these bottom features, this means these are not important. I will say not important because we can see here, this is not any percentage, but it is more than 80% important for the model. Square foot living, right? Any questions still so far? Any confusion? Okay, now that was the bar graph we were looking at it. Now we will look, this is the picture again, where you can see with the comparison of your bar chart, right? And decision tree. Here we can see square foot living and year built is a highly used features by the decision tree regression inside the model, right? And the same feature I have highlighted here in the blue and the red color. Red belongs to your year built and square foot living belongs to your blue box. So these two features are the most important features for your this model. Okay, this is how like we can see now, maybe if you see now condition and bedrooms are not using by the model, then we can drop them, right? We can decide I'm going to use these features only. But as a layman, if you think we might think if the number of bedrooms will increase, the price is increasing, right? But see what the model is using inside it. Okay, so the what features importance doesn't tell you. What is the disadvantage of the feature importance? The disadvantage of the feature importance is that it does not tell us the positive and negative relationship. right? Because it is in the bar graph, it is only showing you the positive value, top end, right? But in the coefficients, you will come to know the positive and negative, right? In the coefficients value. But it don't actually know the relationship with the most important features and the target, right? Because in this, we will not come to know the most important features, the relationship between them, what type of the relationship they have, okay? We can if you know, by looking at the top features, then we can do some EDA again, right? And then we can create the model again. These all steps are very useful before moving ahead with the deployment, because it's a time when your model is ready, it's a time to see inside the model, right? Now, any questions still so far? This is the optional part, okay? So if we have a time after completing everything, then we will come back here, okay? We will jump onto the here code along first, okay? So this is the main repository link if you want to do together. And this is the today's code along. I have opened it in my local repository, so I will go with that. Here we go. Okay. So this is a today's code along. We are going to use in this the data set, predict the life expectancy based on the given feature. Which feature we are going to find out which features are most important and how you can get that. Okay. So now in this lesson this is the same in the code along. After doing this, extract the feature name using your sklearn version 1.1 objects. How you can visualize the coefficients, which I have discussed in the slides. Okay. Save the models to a job.lib file. Why we save it? So you can use it later on whenever you want to see again and to do some work with your model. The data set is here. If you want, you can download from here as well. Otherwise, data set is available in the repository as well. So this is the same like the old work which you have done earlier as well. I will not go through this. We will jump quickly to the over this part. This is a EDA which we do pre-processing. Okay, we are using the column transformer here, right? And we are preparing the preprocessor, make column transformer using. Okay, and here we are just displaying the features. From here, I will start. So once your preprocessor is ready, right? After doing the info, you are separating the target, you are setting the X and Y features, and then you are making using the column selectors, categorical, numerical, and then you prepare the preprocessor. This is the time to fit it now. We are fitting on string. Okay. This is the data frame. We are just transforming the data. Here, the columns preprocessors get features name out. This is, I have shown in the first slide of the lesson, how you can get the features name from preprocessor, right? So this is how you can use here. You can set this parameter columns is equals to preprocessor dot get features names out. Okay. And then index is equals to xtrain index. We are setting the index with it. And this is your test data. In this preprocessor dot transform xtest column is equals to, again, we are using this method. Okay. And now look at the output. This is your output. This is your data frame. Okay. In this, you have the features year, mortality, deaths, alcohol, expenditure. This is the other, like the features polio and this. and the target value is your life expectancy. Here, the features are not scaled. We need to scale it. It is important. In case if you don't scale it, right, it will create a problem in the feature importance. Okay, we need to do that. Now look at here. So anything you see awkward here in this data frame? Here at the top in the column names?
Pipeline one.
Yes, right? Because we are getting the features name from the preprocessor. Okay, it is coming with the pipeline first underscore year. It is automatically taking this, right? We are not like printing the names manually. We are just getting it from the pipeline, which we have prepared earlier using make column transformer. Okay, so now what we will do? If you want to take out this thing, you want to get rid of this thing, preprocessor is equals to make column transformer numeric pipe, numeric selection here, categorical, this is the one. You need to set this parameter as a false here. Okay, so you need to set this parameter as a false here. Then you will get here the name clearly like this way. Okay, so this is a feature you need to make it. This will help you to get rid of that pipeline underscore one, that prefix. Okay. Now this is the same custom function you are using, right? So in this, we just set the different metrics based on the regression models. Okay. And now we will start with the baseline linear regression model. Okay. So here you have sklearn linear model. We are importing the linear regression model. Here we will create the instance of your regression model. Now you fit onto the data, training data, and you will call this function. Evaluate regression function will give you the output of the matrix. This is your R square, MAE, RMSE. Okay, so this is a simple process, right, which you used to do with the modeling. Now look at this picture. If we want to look at the model like here, what the model is saying with the new data points in the output, how it look like. If you look out this right side, this seems to be the flat relationship between your model, right? This is the like showing predicted value, higher rate, right? This is the residues on the y-axis. Okay, the far away from this line from here, higher the arrow, right? This is the number of the residues. This is your Q plot, the left side. Here we can see the distribution of the data. Is this normal distributed or not, right? If you remember, there is a quartile range, 25%, 75%, and you have another 3%, right? So in that, what does it show? How is your data? How much percentile of the data is normally distributed here? If normal, this is close to this line, right? This your trend line. But after quantile range from here, it is deviated from here, right? It is not normal distribution anymore, right? So this is like showing us how the data is distributed. Is it normal or not, right? Now, this was a simple, like we were exploring the data, we were extracting the features name, right? We were looking at the predicted value output here, right? Now, what is our next important goal? This is we need to focus on extracting and visualizing the coefficients. Okay, so how would you do that? We are making the custom function here. Okay. Now we will call it get coefficients. We will pass the model name here. Okay. Now coefficients we are converting it into the series. This is linear regression dot coefficients underscore method to take out the coefficients. Index is equals to linear regression dot features names underscore in underscore. If you remember, we discuss it if you are interested to take out the features name from model. So model is saving itself. Here we are trying to get the coefficients from the model and with the features name. So you can see what are the coefficient value belongs to each feature. Okay. So we will convert it into series. And then this is the intercept value, y is equals to mx plus b. And now look at this value. This is not showing all features, right? But it is showing you the coefficient value used for year, adult mortality, infant deaths, alcohol, percentage expenditure, and so on. Okay. Any questions till so far? Okay. So now we can see after decimal, this is a big number, right? If you want, you can format it. How many numbers you want after decimal? For that, we will use the pd dot set options display float format lambda x. This is a format for x up to 4 decimal we want to show. Okay. So we are using this lambda anonymous function and then we will set it. Now we will sort the values. Here we have sort the values. Now this is, we can see when you sort it, right? In this, your negative coefficient value is coming on the top, right? We can see intercept has a highest value, right here. Then going down, it is showing all countries here. See, right? And then it is showing other features, alcohol, BMI, adult, mortality, country Denmark, polio, etc. Right? Like this. So this is all showing the coefficients. Okay. So now it's showing us based on the coefficients, positive and negative value, how they are related with the target in a positive way or in a negative way. Okay. So in this, we can see here, how can we handle this many coefficient in our visualization? It's tough to see because we have a lot of, right? You have two options for that. You will only plot the most and positive, like the coefficients which you think I want to see, right? Or you can also plot the and most negative numbers as well, coefficients. Okay. And then second option is separate out OHE countries into separate graph. Okay. So we will try the second option. We will separating the OHE country, one hot encoded countries. This means categorical variables, we are going to separate it. Now, what we will do for that? We will take out the, like the values, which is starting with the C, country name. Okay. So we will use here this method, list comprehension method, we will apply. We are just putting a condition if C starts with the country. Okay. And now if we check the length, it's a 183 count of the your country features. And now we will plot it. Now look at the graph. This contains only and only categorical feature country. Okay. If you look at the top, in which country the life expectancy is looking high? This is country Greece, then France, then Canada, and then Israel, right? How it is like related? In this country, the life expectancy is higher, right? So this is like it is a help. This feature is helping you to predicting positively the life expectancy, positive prediction, right? Using this. But if we go with the other countries, you can see here, country Sierra, country Angola, this is Chad, Romania, and other countries, this is negatively related. This means life expectancy rate is low in this country. If we look at this graph according to the coefficients value. So this means this contains a negative relation, negative coefficient of the features which is used by your model. Okay. Now, in this, if we plot everything without countries now, we have separate the things, right? We have separate the countries from the whole features. We plot the graph, see the relationship of the coefficients with the target. Now we will look at the relationship of the target with the other features except countries. Okay. So now look at this graph. Here it is showing these features: status developed, year, schooling, sorry. And here at the bottom, it is showing status developing and intercept. How it is related with the life expectancy? If we look at here, status developed, this means country is already developed, right? The life expectancy rate, it has a little contribution in life expectancy, but we can't see here anything. This is very small contribution, right? But if we look at the here status developing, this is negatively related to your life expectancy rate, right? And now if you look at the intercept, such big contribution, the intercept feature, but there is no use of that because we can't expect the life expectancy in a negative way, right? We need the high rate of the life expectancy, right? A rate in the country. So this is highly negatively correlated. It is predicting negatively, like the life expectancy rate, we can say the low, right? It is going in the negative. So if this is not a relevant, like the question, or we can say looking very odd with this feature. So what we will do now, if we look at the graph, we can remove this feature. We can try without intercept now, how it look like. Okay. We will fit the model again. Here you need to use the parameter fit intercept is equals to false. Okay. So it will help you to make a model without your intercept. Okay. Now look at the graph. Can anybody tell me, is there any difference when we are plotting the graph without intercept? It is the second one, right? It was the with intercept. This one, right? But it seems to be same, right? Okay. So now in the graph, there is no like the difference in the visualization. Distribution of the data is in the same way, right? But if we look at the coefficients now, look the difference. There is a change in the coefficients. See, year, adult mortality, and then we are going down here, right? But if I show you the coefficients with the intercept, this was the result, right? Intercept was coming earlier at the top, right? And then countries, then other features. But when you remove the countries and your intercept, it changed a lot in the value, right? This is like, because it is not using now intercept values, it is changing its value, it's on, right? So coefficients is changed. Now look at the result. Now we will plot the graph again with the countries only, but it is without intercept. Okay, see the difference. Now country Greece is showing all negative, right? Earlier it contains some countries here, the positive relation, right? But here this is all negative. Now the country Romania is saying the negative life expectancy. This means predictive power of this feature country belong to this value is negative. right? And then we will plot without countries now the graph. Now look, see the difference. There is a no intercept, right? So if you look at it here, status developed, status developing, there is a major difference, right? Earlier with intercept, status developing has a negative effect on the predictive, right? With the negative coefficients. When you remove the intercept, status developed and status developing, showing the positive coefficients value score higher, and showing the model is using maximum time these coefficients value to predict the life expectancy rate, right? And this is other than we have a year than schooling, seems to be no contribution, right? Now, this was a case like if you have all the features, how we have removed the categorical feature, how we have like see the feature importance, here coefficients importance with or without intercept, with or without countries. Okay, any questions till so far? Is it making sense? All right. Now we will jump with the no countries. Now this was the first scenario where I wanted to show you if you are keeping the countries, if you are not keeping the countries. Now we have seen if we remove the intercept, country is not giving the good contribution even with the intercept as well, right? So I would like to drop that feature. Okay, so we will drop the country feature from our data set. Now we will jump with that one. So here we will apply the same process. Okay, and now we will see the without intercept and without country. Now look at the difference. Is it better now? The normality condition, the distribution of the data, right? It is less deviated now. Higher the quantile range, less deviated from here, right? Earlier it start deviating from here. Okay, so there is a little bit difference when we drop the country feature. Okay, so because the closer value to this line, good is the distribution and model. Okay, in the normal distribution. And now we will fetch the using get coefficients function again, which we have made here, the custom one. This one, we will call it again. Okay. Now we will plot the coefficients importance again of this model. Now look at the result. Showing any difference? Did anyone notice? Anyone? Right? So we got a status developed, status developing, and income composition of the resources as well, schooling, infant deaths, right? It is like saying if infant deaths is increasing, life expectancy here, it is also giving the positive relation, right? But it doesn't make sense here, right? With this feature. So we can dive deep more with this feature as well separately, how it is making contribution, right? It is very awkward to see like if this is increasing, the life expectancy rate is increasing. Okay. So now in these two features, status developed, status developing, both features are used, right? But I think there is a major difference in develop and developing, right? If you want, you can use the one feature only out of this. I will take the only status developed because this is a more time used by the model than this one. Okay, because in this, I don't see any other major difference. Now, we will take another case, dropping the categories with one hot encoder. Okay, so we will take this case now. In this, what we When we will make a pipeline of the categorical, we will say here one hot encoder drop if it's a binary. Okay, so it will drop that. It will only contain the other features except binary. Okay. And now we will fit onto the model here again, pre-process the data. Here we are fitting it again. And now see the here over your Q plot again. It is not making too much different. It's almost same. Now we are interested here only looking at the coefficients like the importance, like the feature importance. Now see the difference. When you have dropped the categorical feature, the binary one, how you're like the which features are used most of the time with this, which are important. See, of resources is come on the top, right? This is the topmost high rate of the life expectancy here. Here the schooling, right? Infant deaths, again, total expenditure, alcohol, right? So we can see how if we are removing the features based on the coefficient importance, right? I have removed the one hot encoder feature, then there is a big difference in the feature importance, right? Here, if you look at this, now status developing used by model is now showing negative predictive power, right? Negative. HIV AIDS, this means when will this decrease, the life expectancy increase, right? In this case. Now we will take the next thing. What are the most positive coefficients and what are the most negative coefficients, right? So till so far we have like discussed the different scenarios using the different features, right? With the country, without country, with intercept, without intercept. Then we have removed the one hot encoder feature as well. Then we look at the features, right? Now we will do what are the most positive coefficients and what are the most negative. So first of all, I would like to see with the one feature, this is the infant deaths, how it is related. Now look at this graph. This is on the y-axis, this is life expectancy, and this is infant deaths. If you look at these, when the infant deaths is increasing 1750 above, life expectancy is your going down here, right? And if it is less, this is increasing, right? So this is, we are checking it after removing the one hot encoder feature, right? So this is also in the positive, right? This is like increasing in this direction. This is increasing in this direction. Both are called like this is a positive coefficient, but they are going in the opposite direction here. Okay. Now, if we want to look at it in a this way, we want to like dive more into this, see the relationship between these two features, how the infant deaths are connected with the target. What is the relation we can see here? Is this positive or negative? Anyone? This is, we can see the line is going down, right? So this means when the infant deaths is increasing, the life expectancy is decreasing, right? So this means they are connected in opposite direction. This is not positive relation, right? But it is contributing to helping the model to predict the correct value, right? And then this is, you can use the lowest, like this method is equals to true when you want to dive more in this. This is here, it will show you the clear picture how the relation is in this. Up to 250, or we can say here 150, this when the rate of infant death is till here, life expectancy is increasing, right? This is in the, like in this direction. But after this is going little bit like this, then it is consistent from here, right? So this is how it is connected with your life expectancy rate. Okay. So now we can think about it. We were doing the coefficients, importance, feature importance using linear regression with the different cases, right? So now we will do the same thing with the random forest as well. Okay. Make a one new function here, plot coefficient simple. Okay. This is for this one. And this is, I made some changes in the figure size only. This is the random forest regression now. Earlier we have seen which features are mostly used by the linear regression, that we were talking about it. Now we will talk about which features are most of the time used by random forest. So we will fit it, check the accuracy, and now we will get the features name from the model using features underscore names underscore n. Okay, so this is the features name, right? See the importances. When I get the importances using this, okay, it is showing year at the top and then these. Okay, now this is the, we will plot the graph. First, here the using your without countries. For the comparison I have plotted, we have already discussed this. This is for linear regression. Now we will plot here for the decision tree regression to see the comparison. So which features are used by the linear regression model and which features are most of the time used by the decision tree regression. Now look at the result. Here, the top features are positively, top and positive, income composition, schooling, infant deaths, total expenditure, alcohol, BMI. We can say BMI very less, so I will consider only these two. Okay, negatively these one. But decision tree, see, look at the result. There is a no negative correlation because feature importance does not show the positive and negative relation. It will only tell you the name of the feature with its score value, okay, in the decision tree. So it shows HIV/AIDS. Okay, this is most of the time used by the model. Okay, so definitely this is predictive power, like tell you if most of the time used by your model. Income composition of the resources, adult mortality, schooling, under 5 deaths, BMI, thinness, and 9 features, right? So in this case, we can see if HIV/AIDS cases will increase, it will definitely decrease the life expectancy rate, right? So now what are the top 5 most features? If we look at these, we can say this, schooling, and under 5 deaths, right? So now if we remove the adult mortality is one of our feature, right? Then what will happen? Okay, in this case. Earlier we have removed this feature. Now we will remove this feature, adult mortality. Okay. Because of these, the expectancy rate should be decreased. Now see the difference. Here, again, the feature importance is like this. Okay, for the decision tree. Here, HIV, and then this. Now it was the third most important feature for the model. Now under 5 deaths will come, right? And then we will plot the importance here again. This is the same thing. There is no difference. Okay, so now here, this is your final till so far we have used the different cases with the different scenarios, which feature can be important using random forest regression and which features were important using the linear regression. And we have dropped some features, right? And then see the difference with the different scenarios. Now it's a time to save your model. Okay, the final one. Why we save the model? Because we can use it for the next time. It will save your everything. You don't need to do anything again. You can just unload it and start using it. You don't need to do any pre-processing again. You don't need to do any analysis more. Okay, so this is my final model. Okay, using the same features which I'm using for the random forest. So it does not contain the adult mortality as well. Okay, so these are the final coefficients I made. And then we are just evaluating it. And here, the library which you need to import. This is your job lib. We are using library to save the model. This is your OS library. Here we will make a dictionary. In this, we will say xtrain. This is your data for the xtrain. This is the name. This is your value. Key name, value. And then we will save the preprocessor here. Model name, another model name. Okay. We can see it is saving the preprocessor here. Okay. And we will make a one folder models. Okay. You can make it in your local environment. And then you will run this command os make directories folder exist okay is equals to true. It will create that folder. Okay. Now folder plus you can name the model name like this way, but you need to add the extension .joblib. Okay. And then you this is saved now inside the model when you will run it. Okay. Now this is, you can see the keys like this way if you load it again. Okay. And that's all for today's class, the code along. Okay. So in this, we have seen today feature importances, right? Top one, using the your like decision tree regression, linear regression, right? And what is the difference between glass box model and other model? Now, I have one challenge only for 5 minutes. Okay. If you only need to answer 2 questions here. Okay. This is the same notebook, warm-up one, which you have used during the start of the lesson. And you need to answer these 2 questions. Extract and visualize the coefficients and plot the n positive and n most negative features and interpret them. Okay. So here you will use the get coefficients and you will plot the graph. Here you will find the like plotting the graph and just interpret what are the top like the features 2, 3, 5, whatever you like. Okay, just interpret them, how they are positively, negatively coefficients related, and which are the top features using or contributing with the model. Okay, so I will open the breakout room for 5 minutes. I will